Welcome back, everybody. Um, I'm going to go ahead and start on the O's. Wow, we've done a lot. Here we go. And so the first function in the O's is called O. And it's a funny looking name, but it makes sense because this is basically trying to be like the composition operator, which I mean, I could zoom in all the way and you still won't be able to see it, but you can Google mathematical composition operator. It looks like this. It's like a small O with a, you know, space, like a cutout in the middle of it, like this, but smaller. And the composition operator is like the whole basis for function composition, both the compose function and the pipe function. It even says see also compose and pipe. But this one is a very specific version of compose. It's right to left, and it only takes two functions. So you can only compose two, where if you use the compose function, you can list as many, you can compose together as many functions as you want to. So that's one thing. So um, let's take a look at the function type signature. So it takes two functions and a value and returns a value. So the first function takes a B and returns a C, and the second function returns an or takes an A and returns a B. Then you give it the A and it returns the C, right? And since we're doing right to left, this makes sense. Like you give it the A, and the A goes into the last function, the second one, um, and returns a B, which becomes the argument for the first function, and that returns a C, and that's what you get back when it's done. So it takes two functions and returns a function. Oh, you know what? This is wrong. It says function f and g and returns a function, but it takes a argument too. So yeah, this is incorrect. Um, I have seen some things that I thought like, this is iffy documentation, but I feel like this is just flat out wrong. Maybe I or somebody else should submit something. I'm not exactly sure how or to go about doing that. But so anything that you want to do with this function, you could do with compose. But this may be more of a concise way to do things where you only need to compose two functions together. And then there's another requirement. So let's read this. O is a curried composition function that returns a unary function. Like compose, O performs right to left composition, like I just discussed, this one first, then this one. Unlike compose, the rightmost function passed to O will be invoked with only one argument. So that's the second thing that's different between this and compose. Compose, the first function in compose can take any number of arguments that you want, but then each additional function only takes one argument unless you jump through some hoops to make it work. Also, unlike compose, O is limited to accepting only two unary functions, right? So, like the type signature says here, takes one argument, this one takes one argument. The name O was chosen because of its similarity to the mathematical composition operator, which is that little thing. And yeah, and the other thing is nobody knows how to type this function composition operator. So that's why they use the O. Um, Looking at their documentation here, yeah, it's good as anything. Let's just grab it. Uh, okay, it's a bit messy. So we have this classy greeting. It takes a name, and then it just returns the string. Name is an object in this sense because we're getting named out last, and we're doing the names Bond, James Bond kind of thing. And then we have this uh, composition of the function to upper and classy greeting, and then we call it. And then this is a separate function, so we'll look at that in a minute. Let's just comment this out. So we need to log it. And so, like, I couldn't put r.log here because it only takes two functions. So I have to log it like this. Save that. And we get the name spawn, James Bond, all capital. Um, let's look at it like that, right? So, very, very straightforward, really. I mean, just two functions. We first we pass the object to classic greeting, and it constructs this string with spaces and formatting and all that. And then we take the result of that and pass it to upper, which uppercases everything. That's where we have yell greeting, right? So again, we could do the same thing with compose, just change it to from O to compose, and we get the same thing, And if we did this, we could do r.tap log, and then we wouldn't need to log it like that. We could get the same thing. But if we did this with O, we're going to get some sort of error, I'm assuming. Yeah, let me get an error, and it says many things. Type error, blah blah blah, does not have a method called to uppercase. Yeah, I'm not sure exactly where that how that error is happening. I mean, I know it's because we're passing too many arguments to the function, um, but I don't want to have to try to figure out how that maps to the error message that we just saw. So yeah, that's one thing of compose. And then here's another one. We're taking the composition of r dot multiply 10 and r dot add, so right to left. So we're going to pass this number -4. It's going to give us, we add 10 to it, we get +6. Pass that to multiply by 10, so we get 60. And if we log it, we get 60, right? So let's see how they go about creating that function. Yes, it takes two functions, fg and a value x. And this is what it's doing. It's applying it. Like first we apply g to x. Whoa. Sometimes it helps if you just wrap it in parentheses. So first we apply a function called g to x, and that's going to give us back something. And then we apply f to that, right? And then if it was the compose function, we could keep going and apply e to that and b to this. And then you get all kinds of, I might have gotten a parentheses wrong, but um, oh, yeah, like that. And you're just nesting everything. And that's what compose and pipe does. It allows you to unnest so that you could write it like if it was pipe, you could just say D, you could- let's do it like this. You could just say D, E, F, G, and then call it with X, right? And that would do it. And then if you wanted to do it like compose, assuming you had these functions defined for these letters, and then you would say D, F, E, D, like that. And it would do this. Or am I getting this mixed up? I am. You would do D, E, F, G, because we're applying G to X, and then F to the result of that, and then E to the result of that, and then D to the result of that. Yeah, so if it was pipe, then it would be B, F, E, D. Right. So yeah, that's the O function, which essentially is just it's called a function, but it's really more like an operator. But of course, in JavaScript, operators are implemented as infix functions. It's just we don't have any control over that, and we can't really make our own. I think it would be cool in Haskell. You can do something like add 3, 2, and that would give you 5. But you can also do it like this, which I think is just easier to read. I wish you could do that in JavaScript, but you can't. So if somebody could get on that, that'd be great. Otherwise, let's move on. Let's check out object of, see what this does. Pretty short description, I should say. It takes a string and it takes an A and it returns an object where the string is the key and A is the value. So it creates an object containing a single key value pair. This is pretty straightforward. Um, yeah, I like this. Let's use this. All right, so we've got a function here, composing functions together to create another function. Get my parentheses off. Let's see, there's that, that here, that there. And let's put this on a separate line. So we're composing two functions, and let's throw an r.tap log, and that way we won't have to log out. We won't have to use the log function separately. And I'll even put this on its own line. So we're passing an array, 3 strings, foo baz, and we're going to map over this list, and we're going to call or apply object of with a string of match phrase. Right, so there's the string right here. And then we're passing in an A, and in this case, A is an array of 3 items. And so what we'll do, let's look at it. Yeah, here we go. So we're looping through, and we're taking the string match phrase, and we're creating an object. So it creates an object containing a single key value pair. So we're looping using map. So for each object, we're creating a key value pair using the string. So object of match phrase foo, match phrase bar, match phrase baz, which is what we've got here. But then we're doing it again. Then we take that whole array and create another object with the key must. Now that's the string, and everything I have highlighted here is the A. And so we get this object, this outer object with one key must, and the value is this. So just yet another way to create objects out of arrays, arrays out of objects. There's so many different variations of how you would want to do it. Um, and then we're logging it, of course. And then we could do it. And actually, no, I almost always use pipe because I think left to right or top to down is easier to read. But because of the nested behavior of this output, I like using compose here because it's really like saying like make a an object with a key called must, and inside of that map over the data and create objects, nested objects inside of it using match phrase as the key. So this actually like feels like the same order that I'm getting it back here. You know, it could easily be pipe. We could just move everything down, and this should give us the same thing. Oh, wait, pipe. Yeah, and we get the same thing, right? Foobar baz. Yeah. Yeah. So object of, and we're going to look here. This the reason they use of has to do with um, I want to call them monadic structures. You know, things like functors. A functor is not necessarily a monad. And then there's monoids. You know, like so. First, you have a data structure like an array, which is a functor. It's also a monoid, and it's also an endofunctor. Actually, I should say it's a functor. It's also an endofunctor. It's also a monoid, and it's also a monad. You know, so these are like more specific versions of that. And I don't want to try to get into it. I want to keep focused on just the functions here and not try to explain these algebraic data structures. Like I might be using this terminology incorrectly. Um, but just to stay on track, the reason you have these of methods or of functions is to be able to create something like a functor and then have a function that takes a value and puts it in the functor, right? Like so, like if you think of these boxes that we sometimes compose together, you need a way to put something in the box, and the of is this function, this like known function, a known way of putting something in a box. And so I'm getting ahead of myself a little bit. Let's clear this out and clear this. So let's say we have an array and we're going to call it a monad because an array is a monad. And for this purpose, we're treating it as such, not just as a container like for a list. Because the monad or this list has a map method and it also has a flat map method. And it it adheres to the two monadic laws, one of which is identity and the other one is composition. So if it adheres to those two laws and it has a map method and it has a flat map method, then it's called a monad. Uh, but how do we put something in there? Well, I mean, we could just do like three, you know, and that would give us what we want. But if we wanted to use a function to do that, we could use the of function. So if we did log uh, r dot of, and then we tell it what we want, let's say monad, and then three, then we get an array of three. It's that easy. But see here in this example, we have a maybe type. And this is something you can find in Sanctuary JS, which is like almost like a branch of Ramda where it doesn't have 240 some functions. It has like 30. But it relies very heavily on these structures like these algebraic data types. That's, I think, what they're called. Like maybe, and maybe has two flavors. It has just with the value inside of it, and it has nothing, maybe dot nothing, which is like alternative to null or undefined. It's the concept of instead of throwing an error, you get back an error as a value, which will keep your program from crashing. One reason Sanctuary JS was created was situations like this here, where the nth could return undefined, and we don't want to do that. We'd want to return, like here, we could say we're maybe going to get back an A or maybe nothing. So undefined could crash the program, or we'd have to guard against it. Same here, maybe a string or maybe nothing instead of undefined. So as simple as this looks, where is it? It has powerful implementations. And in order to create these things like a maybe or something else, you have to have an of function. You have to have a way to put the value into the box. And so when I say box, I mean like an array, a maybe. A lot of times you'll see similar ADTs, uh, algebraic data types called result, which comes in flavors like some or none. No, some or error, I think. Yeah. And then an object is not one of the, it's not a monad. For example, an object doesn't have a flat map method on it. However, in Ramda, it does treat it like that. Um, but, so it depends on what mathematical laws the function adheres to, as well as what methods are on that object. Um, so if an object doesn't have a map method, it's not a functor. But if you implement a map method, then it is a functor, right? So this is probably not something you're going to use unless you're using these ADTs. And soon, not soon, but at some point, I do intend to get into it. I want to look at Sanctuary JS, and I'm still in the meantime learning more about these types, uh, things like maybe, result, either, and then creating my own. Uh, yeah. So let's look at the function definition as well. Um, it takes a function which takes anything and returns an object of anything, right? So here's our example, an array or the maybe, uh, we'll call it a maybe box, right? Just a container, a data structure. And then it takes a thing, an A, and it returns an object with that thing in it. So, it could be 42, but it gives you back the value inside this container. So it says given a constructor and a value, it returns a new instance of that constructor containing the value, right? And it dispatches to the fantasy land of method of the constructor first if it's present, or to the of method last if present. And when neither are present, it wraps the value in an array. Okay, so it falls back to an array. Note this of is different from the ES6 of, right? So the ES6 of, like if you make an array of two, You get a sparse array. You get an array with two empty items, not two items with undefined or two items with null. You just get these two items. You can't map over those things. You can't filter. Uh, so it's not all that helpful. Like you could, I think you could do like dot fill and put some tacos in there. Click the right button. Now we get an array of two tacos, but like we're making a sparse array, then we're going in and filling it with one thing. Then you can map over that. Um, so what you're doing here is you're creating a new array with a length of two. So then they said, well, that's not that useful. So let's do an array of method. And then you could say two, and that's going to give us an array with just a two in it, like that. And then you could do three, four, you get two, three, four. But if you did an array, if you just use the array constructor and you just pass three values into it, sorry, I want to make sure I save. We still get the same thing, two, three, four. So the only thing is that when you only pass it one argument, that's when you get the sparse array. That's why they created the array.prototype.of method. But this of is different, right? So this is just a function that takes a value and puts it inside a box. The box could be an array, it could be a method, it could be anything, or right, sorry, an array, or maybe, or any other ADT, algebraic data type. That's what up does. You're not going to use this much unless you're using it like this, but it does need to be there. It's kind of like the identity function. It's like if you have a functional programming library that didn't have identity, like it's missing this crucial key basic ingredient, even though you might not use that ingredient. I want to check the implementation of this. The CTR means constructor and value. At first, it looks for this Fantasyland thing. And if that doesn't exist, then it looks for this other Fantasyland thing that doesn't exist. So then we just say is it a function, blah, blah, blah. Yeah, but basically, in most cases, like I've just created, it's just doing this. It takes, oh, well, first it looks to see if you pass in a constructor. But if you didn't, it just puts it in an array, which is kind of like our default data structure, like that, like our default monad in this case, or a default functor. It's several things. But anyway, the point is that the function implementation is super simple. We could just say of and take a structure. I don't want to call it, I'll just call it structure. I want to call it a struct because that kind of means something else. And then if we curried it, the val, or just say x, and then we would just put, how would we do that? Yeah, you couldn't really choose if we were going to make our own. Really, it would just be like what we just saw. We take an x and then the x in an array and return that. And so if we did of 42, we would get an array of 42. Guess you could do x's And I guess we would need to spread the x's. Nope, x's is not iterable. Oh, it's not. But it could be if we did it like this. Is that right? Ah, but it's we need to spread it in here as well. And so you can see why you need this flat map method. So that's right. But if we wanted to create our own, see, we get this nested thing, but we could do r dot flat map. Is it flat map or is it chain? Chain means the same thing, just different terminology for the same thing. I think that'll work. No, it's undefined. Oh, yeah, invoke it. R dot chain. That's what it was, I think. No, that doesn't work either. R dot chain takes. It takes a function. So, yeah, what I'm trying to demonstrate isn't that useful or even relevant here. Um, but anyway, the key is that of takes something and sticks it in, or it takes a structure and a value, and it takes the value and puts it into the structure. Yeah, so that's of. Um, let's do one more. Let's do omit. This one's pretty straightforward. Omit is like delete. You could take, let's use our list. I have this function that creates a list that looks like this, 1, 2, 3, 4, 5. And I think what we could do, yeah, since it's JavaScript, we can still use const and then make a list from d.list, and we still have the same thing. But then I could make another one called list underscore just to have a different name. And I could say delete, like the delete keyword. And honestly, how does the delete keyword work? I don't think I've ever used it. Yeah, I'm trying to delete an element. Um, I honestly don't know how to use delete. But that's okay. I mean, I can just show you. We don't need to learn how that works. We can just omit. It returns a partial copy of an object, omitting the keys specified. Oh, I'm sorry, this is using the object. I was thinking of the array.delete, but this is for objects. So I should have started here to the beginning. First, we pass it an array of strings, one or more, and then we pass it an object. Object keys are strings, values can be anything, and we return a partial copy of an object omitting the keys specified. So we just remove the keys. Let's just use this. I should have read from the beginning instead of making assumptions. So here we're calling the emit function. We're passing it a list of keys. So the object with the key or the property with the key A, the property of the key D. and then some data. So we have the A, the B, the C, and the D, and we're going to omit A and D and just get back a new object that only has these guys. And that's what we get, you know. So if we did E, which does not exist in the object, you still get back the same thing. It's just like, oh, that's not here. Because in JavaScript, if you try to mess with the property of of an object that and the property doesn't exist, it doesn't crash or throw an error. It just gives you undefined, which is something I'm not a big fan of, but it is what it is. Um, and then it says see also pick, and we looked at pick. We looked at pick and prop, all kinds of them, but we'll get back to them. But I'm not going to look at it right now. So yeah, it does what it says. You know, tells you I want to. These are the things I want to get rid of, and here's the list I want to get rid of them from. Not a list, but an object. And let's see what they're doing. They're creating this very procedural, very imperative. We're creating some objects to use temporarily, starting with the index value of 0 and just going ahead and getting the length of the props that we're passing in, the strings that we're propping in that we want to omit. And then we loop. Yeah, as long as the index is less than the length, this just tells us how many times we loop. We take the index and then, uh, yeah, the index object, and we find the property that matches the name. Well, if we find the names that we pass in and pass in the index, that gives us the name of the thing we're looking for. Why are we saying that equals one though? I don't know. Doesn't matter. But here's where it's basically doing. It's just basically saying that if it has its own property, that uh, we're not reaching out into the prototype chain. We're just focused on the object that we literally passed in. And if it is not one of these things, we have the not operator, then we stick that property value into the result, and then we return the results. So basically, classic while loop. Nothing too complicated, but it's very handy that it exists. And then I'm going to stop here. We'll pick back up on the on in the next video because this is something which is also known as the P combinator. I want to take a little bit more time on this. Yeah, that's what did we look at? Did we look at all of these? Oh, object of, omit. Yeah, we went through several. Um, so anyway, thank you for spending your time with me. Tell a friend, and I'll see you in the next video.